All right, guys. Let's go ahead and go over this FRQ here. A lot of this is going to be review. Some of it will, the very first question will be kind of the newer stuff that we have seen. But there's a lot of review in here too. So I like this one because it's kind of like, and the first time I think we can actually do a whole FRQ from an old AP test here because we've learned enough to be able to do that at this point. So let's go ahead and begin here. It says the function f is defined on the interval from -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. And then this is kind of a new idea to you guys. This is an integral function. We are going to talk more about these later in Unit 6, but for now, I'll show you how to work with it. It's pretty simple. It's not a big deal what they're asking us to do. So let's begin. Now, part A says to find g of 3. And basically what that means is we're going to take this g function, which is an integral with an x in it, and we're going to replace the x's, which are here and here, with the number they're telling us to plug in, which is 3. And we did learn this. How do you find the integral of f, if this is a graph of f, which it is, from -3 to 3? Well, you basically just find the area under the curve. So we need to find the area of this triangle here and this triangle here, and then we'll combine them together, okay? Because that's going from -3 to +3, all right? So let's go ahead and begin. The area of the red space is 1/2 the base, which is 1, 2, 3, 4, 5, times the height, which is 1, 2, 3, 4. And that comes out to be 10. So this total area up here is 10. It's a positive 10 because it's above the x-axis. Now we'll do the little green area down here. That one, the height looks like it's about 2, and the base looks like it's 1. So it's 1/2, 1 times 2, which is 1. Now keep in mind, though, this is a negative area, and that's because it's under the x-axis. So the answer to this integral would be the sum of those things. So a positive 10 combined with a -1 makes a total of 9. So that would be the answer to part A. All right, let's go ahead and move on to our next question there, part B. B says, on what open intervals from -5 to 4 is the graph both increasing and concave down? So this is a review of last chapter. So for part B, before I begin doing it, I'm going to write down some useful information, and I would highly encourage you guys to write it down as well. So they tell me that g is equal to the integral from -3 to x of f of t dt. Okay? Now, that means that g is the area under the curve of f. Okay, we've talked about that in part A. Now, here's another thing which is be aware of. Let's think of this way. What is the, don't write this, but just to help you understand, what is the integral of 2x? Well, it's x squared, right? So in other words, if x squared is the integral of 2x, then that means that this is the derivative of that. Okay? So in other words, the derivative of x squared is just whatever's on the inside of the integral. Okay? So keeping that in mind, I'll erase all this stuff here. If g of x is the integral of f, then that means that g prime is basically just whatever's on the inside here, which is f. Now they have a t, I'm going to put x. I'm not going to go into why that is. We'll talk about that more later. But there it is. So G prime is F. Now, we're also going to need eventually in this problem come out G double prime, which means that's going to be F prime. Okay? So, just so you guys know, this is the y value of the graph. So f of x is just the y values on the graph. F prime is the slopes on the graph. So keep that stuff handy. That'll help us as we work our way through Part B. The rest of Part B is stuff that we learned last chapter, and you'll see that come up. So here we go. Okay, so that being said, then let's begin. It says, on what open intervals contained from -5 to 4 is the graph of G both increasing and concave down? So G is increasing when G prime, which equals F, by the way, is positive. This is stuff that we learned last unit. So now G prime, which is F, is positive anytime the graph of F is above the x-axis. So here is where F is positive, okay? And that's where G prime is positive. And we also want to know where it's concave down. So G is concave down when G double prime, which is equal to F prime, is positive. I'm sorry, is negative. Okay, so G double prime is F prime, and that's the slopes of the graph. So F prime is negative when the slopes are negative. And so that would be here and also here. Okay? So that's where F prime, in other words, G double prime, is negative. Right? So based on the coloring we have up there, we could say, therefore, we could say this occurs on the interval from -5 to -3, and the interval 0 to 2. Okay, so all this stuff is from last unit, but what's new about this is that since they give you this equation here, it's important to understand that the derivative is just what's on the inside, and that the derivative of that is just the first derivative of what's on the inside. So, and remember that F is just the y values, F prime is the slopes. Right? So hopefully that's helpful. Let's go ahead and move it along to our next question. Let's go ahead and take a look at part C here. Now for this one, they tell me that H is g of x over 5x, and they want me to find H prime of 3. All right. So if I want to find H prime of 3, the first thing I'm going to have to do is find the derivative. Okay, so let's do that first. H prime is going to be low d high minus high d low. Draw a line and square below. So let's do it. Low d high minus high d low, draw a line and square below. All right. Now they want us to also plug in 3. For x. All right. Now, here we go. We need to find out what is g of 3. Well, we already have g of 3. G of 3 we found in part A, and we found out that that answer was 9. So that's nice that they asked us to find something that we already found to save us some time, but it is possible that they would give you a number here where you have to find it again. So you would just do what we did on part A with whatever number that they asked for, but in this case we don't need to redo it. We also need to find g prime of 3. Now, remember how we talked about how g prime is equal to f on part B? So g prime of 3 is equal to f of 3. In other words, what's the y value at x equals 3 on our graph? What's the y value at x equals 3 on our graph? Well, x equals 3 right about here. And that y value is -2. Okay? So now that I know what g of 3 and g prime of 3 is, we're ready to continue. Let's go ahead and start simplifying here. So we have h prime of 3 is going to be equal to 15 times g prime of 3 we said was -2. G of 3 we said was 9. And the bottom here is 15 squared. 5 times 3 is 15. And since this is an FRQ, we really don't have to simplify this, so we could stop there. I think I'll go ahead and simplify it just because I want to, but you don't have to. This is good enough because from here on out it's just basic math. So we have -30 for 15 times -2 minus 45 over 225, which is -75 over 225, which is -3 over 1, 2, 3, 4, 5, 1, 2, 3, 4. I think it's 9. I think this comes out to be -1/3. I think. I'm just doing that mentally. I'm pretty sure I'm right. But there you go. But once again, you actually could have stopped here to do it. So let's review. What's the big ideas here? First of all, I did the quotient rule. Second of all, for the regular g, you have to do the area thing, which we did in part A, but we didn't have to do it because we already did it. To find your g prime, you're going to find that g prime is the same as f, so g prime of 3 is f of 3, which is the y value at x equals 3, which we see as -2. And then just plugging everything in and solving will give us our final answer. All right, let's go ahead and take a look at one more. So this last one here is saying the function p is defined by that. They want us to find the slope of the tangent line at x equals -1. So the way that you find the slope of a tangent line is basically by taking your function, taking its derivative, and then plugging in the number they give you, because a derivative at a value tells you what the slope is at that point, and that would be the slope of the tangent line at that point. So we want to find p prime of -1. So let's go ahead and do that. So to find p prime of -1, the first thing we want to do is find p prime. Now, since p is equal to f of x squared, and I think it was plus x, right? No, minus x. We're going to have to do a chain rule on this one, okay? We have an inside function, and we have an outside function. So when we do the derivative, we're going to do the derivative of the outside multiplied by the derivative of the inside. The derivative of the inside would be 2x minus 1. Okay, now we want to find that derivative's value at -1. So I'm going to be plugging -1 in for x. All right, so let's see. -1 squared is 1. Double negatives makes 1, so we have 1 plus 1, which is 2. So this becomes f prime of 2. Over here we have Negative 2 take away 1 is negative 3. So what does this represent again? Well, this represents the slope of f at 2, at x equals 2. So let's find where x equals 2. That's right here. So they want to know what is the slope of this line. So what you want to do is you want to find the rise and run of that line. So just pick any 2 points, like I'll do these two. Find your rise. It goes down 4, so that's negative. Find your run. It goes right 2, so that's positive. So rise over run would be negative 4 over 2, which is negative 2. So f prime of 2, the slope of f at 2 is negative 2. And then we still have the negative 3 that we're multiplying there. And so the final answer there would be 6 is our answer. So let's go ahead and see how this thing would be graded. So for part A, finding the area was 1 point, just getting the answer. For part B, they give you 1 point for finding the answer, which was the intervals that we found. That's 1 point. And then the explanation. All right. Now notice they're going to explain a little bit differently than I did, but that's okay. You can read their explanation, see how well you understand it, but the explanations I gave you guys is just as well. Let's go ahead and take a look at part C. Part C, they give you 1 point for doing the low d high minus high d low, draw a line and square below. So that they actually give you 2 points for that, which is kind of cool. And then working it out to get the final answer is 1 point. So that's 3 points. So that was a big one. And then finally we had the last question. They gave you 2 points for accurately applying the chain rule to find that derivative, and then 1 point for the final answer. So that's how that FRQ was graded. All right, so hopefully that was helpful, and we'll see you guys later.